All right, so the next thing we're going to look at is called odds and expectations, and it's a little mishmash of things because odds and expectations use probabilities indirectly to do a few things. Most people, when they talk about odds, they talk about odds as if it was the same thing as probability, and that's not 100% true. Odds are created from using probabilities, and you can also, once you have odds, you can go backwards to probabilities, but they're not one and the same thing, as we're going to see. Now, as far as odds, there's two different kinds of odds. There's odds against an event and odds in favor of an event. Now, in the gambling world, usually odds against is the most common type of thing that's used, like in Vegas and this and that, if you wanted to bet on something, or if you have a horse race, and those things that you see are odds against. And what that amounts to is that you're giving a ratio of the number of losses to the number of wins when you're talking about odds against. Odds in favor is just reversed, or the reciprocal of it, because you're giving a ratio of the number of wins to the number of losses. All right, so this is kind of hard to see, but essentially odds against is the probability that that particular event fails or does not occur divided by the probability that it does occur. Another way of putting it is the probability of failure over the probability of success. Now, this book likes to keep odds as a fraction like that. So once they simplify them down, they'll usually keep them like that, but they do allow you to write them like this. And this is my favorite way to write odds. You write with, B, like I said, it is the number B there would be the number of failures, and the number of successes would be the A. And I prefer writing it with a colon, because then there's no mistaking it for probability. Because one of the things that I find that students do is they get confused between a probability and an odds, and it's not the same thing. And so if you write them the same way and don't distinguish them, it can make it a little bit confusing. And so odds in favor is just the opposite, or the reciprocal. Okay? The reciprocals from one another. So if you got odds in favor of an event, you can easily find odds against by taking and reversing the numbers. All right, so let's go on and look at a couple of problems. Anybody got any questions so far about that? Like I said, it's almost a philosophical thing, but it is important because they're not exactly the same thing. All right, so let's go ahead and look. We're going to come back to this. Let me put this down a bit. So we're just going to talk about the odds first, and then we'll come back to creating a probability from odds. All right. All right, so let's look at a couple of examples. So the first example says if the probability of a horse winning a race is 1/12. In other words, there's 12 horses out there, and somehow it's been calculated that this horse is going to have one chance out of 12 of winning, then how can we find the odds against that horse winning? And the key word here is the odds against. Odds against. All right, now what we're going to do is we got to use the complement rule. And let me just go over here on the board. So I'm just going to put probability of a win. Is 1/12. All right, so this is win. What's the probability that this horse losing the race? Kind of hopefully know about this because it comes from the complement rule. It's what? So the probability that the horse loses the race is 11/12. Does that make sense? Because the probability of the horse winning and the probability of the horse losing have to add up to 1. That's the old complement rule. That even started in the very first chapter of this book when we talked about the complements there. You know, the number of elements in and the number of elements outside or in the complement, they add up to the whole universe. So that thing gets extended here in the calculation of probability, and that the probability of winning and the probability of losing add up to 1. And you can kind of see it there. This is just a showing you a check. You don't really need to do this once you've got that 11/12, but I just want to show you. All right. So that's what should always happens when you're talking about the probability of winning and probability of losing, or the probability of success, probability of failure. They're complements of one another. Now, I just want to point out that I'm showing you here because you're essentially taking 1/12 and subtracting from 1. And some people are probably sitting out there, well, how in the world does that amount to 11/12? Well, it's just because that's the way fractions work. But let me just kind of show you a poor man's way of doing this. If you need to find your complement, you need to find it quick. You don't want to go through all this mess, because essentially what you got to do is you got to write 1 as 12/12 and subtract 1 from it to get the 11/12. Well, what you can do is 1 from 12 is 11, and then keep the same denominator. Same thing, same result.
Okay, yeah, I was wondering if that was going to be right because that's what I did.
Yeah, and that's the what I would say. The poor man's way of doing it, because it's a lot of work.
It's honestly more simpler than
Yeah, but I'm just trying to show you via the complement rule. When you take a probability and subtract it from 1, then you get, in this case, 11/12. Like I said, 1 from 12 gives you 11, keeping the same denominator, same outcome. And that'll always work. All right, so that just shows you. So here's our 2 probabilities. that we're worried about. Let me just circle those because we're going to use them now. All right. Now, that's not the answer we're looking for because what we were given is 1/12. And the only thing that we did was we just found the probability of the horse losing. Now, to find odds against, it was odds against, wasn't it? Yep, odds against. So when you're talking about odds against, the probability of losing or the probability of failure has got to go first or in the numerator. All right. Now it's going to be hard to type that out, so I'm going to go ahead and just write it. It's going to look real mean when you write it out, but I'll kind of again show you how you can kind of skip the junk and move to what's important. Now this is what they call a compound fraction. Looks kind of mean, but this is your main fraction bar here. So it's 11/12 over 1/12. Well, what happens when you do that? Again, I'm going to kind of take you through the long way to do it, and then I'm going to show you how you can do it on the cheap, so to speak. But the reason why I'm doing this is because invariably every textbook has to show you all this. They have to show you, they won't show you shortcuts without showing you what's going on. So if you remember what a fraction means, it means that you're taking the numerator and dividing it by the denominator. So this is 11/12 divided by 1/12. Now, I said this is going to almost seem painstakingly slow to do it like this, but I'm going to show you what's important once I do this. So 11/12 divided by 1/12 is 11/12. Anybody remember whenever you divide one fraction by another, you multiply by the reciprocal. When you do that, these two numbers are essentially 1 because 12 goes into 12 one time. You're left with 11 over 1. Now, the way that Alex does it is they will invariably always kind of write it like that, but they allow you to write it as, and I highly suggest that you get in the habit of doing it just so you don't confuse it with a probability. So there's your odds against. 11/1. And I'm sure most people, if they heard anybody talk about odds, they'll heard something like that. Well, the odds against this horse winning are 11/1. Now, what exactly does that mean? Well, that means, now notice that both of those numbers, 11 and 1, add up to what? They add up to our original denominator, right? 11 and 1 add up to 12, which was the original denominator of the probabilities. So essentially what it means is for every 12 races, 11 of them will be losers and one of them will be winners, will be a winner. You can also kind of write it like this. I don't know that this one lets you, but you can also write it as this 11-1.
Mr. Cruz.
Mm-hmm.
And
And
Alex, will it have to be a colon, or will we have
I
to use
think
it
that
a
I think that
fraction?
they well, I know they let you use it as a fraction, and they'll let you write it as a colon. I just I don't like the fact that they um, let you keep it as a fraction, just because it's easy to get confused and think that it's the same thing as a probability. Now, in this case, 11/1, there's no real danger of that because the numerator is larger than the denominator. But if it were hold on a second, let me show. So let's just do this real quick. Now use this to find the odds in favor of the horse winning. Okay, so that's the same thing. It's just going to be flipped around. So fraction wise, it's going to look like this. And that's not a probability in this case, even though it looks like one, because that's what probabilities are. The denominator is larger than the numerator. So you just got to realize that that is 1 to 11 when you're talking about odds. But they will let you write it either way. They'll let you write it like this or like that. And like I said, I would just kind of encourage you when you're talking about odds is to write them with a colon, and they'll accept that. It's just that they'll also accept it written like a fraction. So does that help you, Nathan?
Yes, Mr. Cruz, thank you.
Okay. All right. Anything else? Anybody else got any questions? All right. Let's just do another one. Let's make sure we get it right. I got another one. Well, we can do a few of them. I actually got. All right. If the a little bit longer, so it'll all fit in there. Okay, let's say if the probability of getting an A is 3/13, what are the odds in favor of getting an A? That's supposed to be a comma, just to be grammatically correct. What are the odds in favor of getting an A? Now we're given the odds. I'm sorry, we're given the probability. What will happen? So the probability of an A is 3/13. And I really think it's good practice. It's hard to do this when you type. So I like to handwrite it. because I like to write them, vertical one over one another. Where it's a little bit hard to see the line when you got it over there like that. So the probability of an A is 3/13. So you can go through and use the complement rule to do this, but I'm just going to kind of assume that you know that. If you don't, I'll be glad to go back through it. So the probability of not an A is what? What's 3 from 13? It's 10. And keep that same denominator. Now, why is that the probability of not an A? Well, if the probability of an A is 3/13, then the probability of the A and its complement, not an A, have to add up to 1. So now you see these both have a common denominator of 13. So 3 plus 10 is 13. 13 over 13 is 1. All right? Make sense?
Can you write that out just so I made sure I wrote it the right way?
What's that?
3/10. Can you write it out?
What do you mean?
What you just said.
I don't know why I'm having trouble getting this. It's supposed to be a 10. Okay. So 1 minus 3/13 is 10/13. Like I said, if you go through the whole thing, then you got to change this to a 13 over 13 formally, and it looks like an awful lot of work. And I always hate to discourage people. But if somebody asks why, then you kind of got to show them this. Because that's what it does. What's happening?
I thought it was a continuous step, not another way of doing it. Sorry.
What's that?
That's why I was confused. I thought it was a continuation of the last step, not another way of doing it.
Yeah.
That's why I was
No,
confused.
it's not. Yeah,
Okay.
it's just that.
Okay.
Like I said, if you understand what's happening, that the complement rule is, in order to find the probability of something not happening, knowing that, and I guess they write it as the probability of a complement is usually the way the book writes it, and the probability of that same event, they have to add up to 1. Let me just put that here. They have to add up to 1. So what that means is you can look at it 2 other ways as well, 2 other ways that are more useful, perhaps. There we go. That's the complement rule. So you can look at it in one of 3 different ways. that the probability of an event happening plus the probability of it not happening have to add up to 1. It's sort of like the idea about rain. If the probability of it raining today is 30%, then the probability of no rain is 70%. That's where that all comes from. You know, the two probabilities have to add up to 1 or 100 in the case of, if we're using percents. So because the probability of an event and its complement, the probability of its complement have to add up to 1, then you can look at it in one of two ways. That if you know the probability of an event happening, then you subtract it from 1 to get the probability of its complement. Or if you have the probability of its complement, you can subtract from 1 and get the probability of that event happening. So that's what it all boils down to. Now, as I had said, is the easier way to do it for the most part is if you've got this event, the probability of this event here, if you take 3 from 13, you get 10, and you keep that same denominator. Same thing's going to happen. You can kind of see it here if you go through the long way. 1 minus probability of 3 over 13ths is 10 13ths. Why? Because 1 is 13 over 13. I guess it is. Just to show you the formal way of doing it. Does that make it any more clear, Catherine? I just want to make sure I'm not clouding it.
No, I totally understand the complement. I just thought when the way you had said it the second time, I thought you were continuing that after you got the 10 out of 13, I thought you had a continuation, not just another way of doing it.
Yeah. Okay.
Yeah.
I might have said something strangely. Okay. So that's the two things we need right here. We need those two things. We need odds in favor. I'll write it sideways just because it's easier to type it. This time, the probability of what we call success, the probability of that event happening, comes first. In other words, I'll write it now in painstaking way. All right, and so when you go through the process, I'm just going to skip to the multiply by the reciprocal. So this is your odds in favor. My way of doing it is like this. The way I prefer to do it, it would be 3 to 10. So again, let's kind of just try to explain what that means. That means for every 13 grades in this class, whatever this class is, 3 of them will be A's, 10 will not be A's. Okay? And that's all that odds in favor are. It's the ratio of number of successes to number of the no success, you could call it. So the success is getting an
That's
A.
a good way to look at it.
What's that?
So your 3 to 10 ratio should always add up to the bottom number, the 13.
Of the probability, of the original probability. Yeah. Yes. The number of outcomes in your, what was originally in your sample space. Now, this could be simplified So I guess that's probably not true to say it is the number of outcomes, but yeah, they will always add up to the number that was in your numerator. In the denominator of your probability. And we're going to use that in a second, because if we have our odds only, then we're going to find out the way to go back to probability. All right, let's see here. What else do I have? So let's just do a couple other ones real quick. And then I'll show you about the what you just mentioned there, Kathleen, because that's an important concept. You know what? So these are the same kind of thing. A card is drawn from a deck of 52 cards. Find the odds in favor of getting an ace. All right. So the probability of an ace is equal to 4 over 52. Or 1/13. All right. So what does that make the probability of no ace? One from 13 is 12. You could have also done it with this. So, 48 over 52. But that's going to simplify down to that when you simplify it down. And, usually it's easier to work with fractions if they're in the simplified form. All right, so we got the two things we need. So it's probability of getting an ace. I'm just going to go ahead and write it out because it just doesn't look right like that. So when you're talking about odds in favor, then the first number is the probability of actually getting whatever it wants, whatever you're looking to get. In this case, it was an ace. And like I said, that's usually considered in a very general term called probability of success. So what's going to happen when you take the reciprocal and multiply, you're left with the valuable numbers of 1 and 12. Like I said, is the Alex will let you put it in like this. And like I said, I much prefer to think of it like this, just so it just shows you that it's not a probability. It's an odd. So 1 to 12. So we can go through the whole calculations again for part B. Well, we can just take it and simply turn them around. Like this, and the same thing. So that means 12 to 1. So for every 13 repetitions of this same experiment, 12 of them will not be aces. One of them will be aces. Will be an ace for every 13 one of these experiments on average. Remember, with probability and odds, you never can guess exactly. You're just saying on the average. Now, again, those two numbers, 12 and 1, add up to the original denominator of 13. So let's go back over to the board here. To the notes here. All right. So if you've got odds of A to B or B to A, and remember, A to B is the odds in favor, and B to A is odds against. Either one of those, if you have, you can find your probability again. Why? Because the two numbers A and B have to add up to be the denominator. Okay? And if then what that A is going to be, that's the number, that's the one associated with the number of successes. That's the one that's associated with the odds in favor. If you have this other one turned around, then you're going to have to just take that into account about which goes there, about which one is the A. Depends on which odds you have. Now, in this case, you're told the odds in favor of a mouse getting eaten by a snake in the wild is 9 to 12. Okay? Then what is the probability it will be eaten? So odds in favor. All right? So what's going to happen here is in the denominator, we're going to add those two up. I'm going to put that first. And remember, we wanted to have the probability that it will be eaten. In other words, this is the probability of success. We're looking at the being eaten as the success. So that's going to tell us which number to put first. All right. So for every 11 times somebody releases a mouse out in the wild, 9 will get eaten, 2 will escape. All right. So which one do we need to find the probability that it will be eaten? Well, it's this first one. So 9/11. If that had been odds against, it would have been turned around 2 to 9. So we would have still used the 9. It's just that it would have been in a different spot. You have to pay attention to what odds is that you're being given. Let me try, see if I can find something. I know I opened up this book, and the book always closes by the time I get around to get it. I was trying to just see if I could find a. It's just most of the examples in there. They do odds in favor. They give you odds in favor. I was trying to see if I could find one. I'm just going to steal that. Whoops. But you got to make sure the numbers are added up. You can't just make up anything. Okay, if the odds against picking an ace is 12 to 1, find the probability of not getting an ace. All right, so the one thing that we know for sure is that the denominator is got to be the total of both of them. Because both of the odds have to add up to the denominator of the original probability. Now, we want odds of not getting an ace. So which one would we use? The 12 or the 1? This is odds against. So for every 13, 12 of them will not be an ace. And you'll kind of remember we did it backwards before when we did the other thing. So any questions about the odds? All right. The second thing in here is called expected value. Expected value. All right. Let me show you the notes and just the definition. All right. So it's the amount you could expect or win or lose participating in a particular event, where P is the probability of an event and A is the amount. Well, what exactly does this mean? Let me see if I can try to explain this to you, because it's a hard concept to grasp. It's not that hard of a calculation, but it's kind of hard to grasp. You know, at the I don't mess around with casinos because because I know what the underlying expected value of these things are, because each one of those games for the house has to have an expected value that's positive in their favor. So over time, as it's played, they can expect to, win 75 cents for every time somebody spins the, roulette wheel, or every time somebody lays down a bet on the roulette wheel. They could expect to win a certain amount. Now, we'd have to calculate what that expected value is. But I'm just saying is in favor is for the house, it's going to be positive, and for the player, it's going to be negative. That doesn't mean that no one will ever win on the player's side. It just means that on the average, doing this a bunch of times, what can we expect per play? Okay. So look at that. Read that number 1 out. And then it'll be right there. All right. So raffle tickets are sold for $5 each. 4 of the tickets will win $1,000, $500, $200, and $100 cash prize. Find the expected value of the gains if 2,000 tickets are sold. So there's going to be 4 tickets out of these 2,000 that are going to win prizes. A cash prize of 1,000, a cash prize of 500, a cash prize of 200, and a cash prize of 1,000. So if we want to find the expected value, how can we do this? Well, we've got everything that we need here. Let's just kind of do this on the board. And I'll make a nice little chart. All right. So there were, see, how many prizes were there? There was 1, 2, 3, 4. Making the chart's probably the hardest. And you don't really have to have a chart. It's just that it makes it easier to do the calculations. All right. So, let me try something else. One, two, three, four, five, six. Okay, that should be enough. Now I'm going to write in here. All right. So this is what we would call event X. Let me just put right here. The prizes were what? It was 1,000. Just write it out. So there's your $1,000 prize. The next one was 500. So this is just kind of a label here to give us an orientation. 200. And 100. and then nothing. You know what? I'm just going to put a 0 there. All right. And then I'm going to put right here an X just to talk about what the particular event is. And we're going to have to think about that a bit. All right. I should have put this over here. I'll go ahead and paste it over here now. So we got the information that we need. All right. Now we got to think about this, about what we're going to put here. We're getting $1,000 if we get the top prize. But you got to make sure that you're dealing with net winnings. And people generally that gamble don't like to think about that. But if we win $1,000 and we played $5 to play this game, what are we actually winning? We're actually winning $9.95, right? Same thing here. If we win that $500 or check or whatever it is, we've already paid $5 to play, so we're really only getting $4.95 out of this. This was the $200 one. So this is $195. And then the $100 is $95. And what would you put right here? Would you put anything there? What's essentially the event that's happening when you don't win? You're -5. Okay? Because you're just giving them $5 and you're not getting anything. All right. Any questions about that? I mean, about how we got that set up? Because I want to make sure we're all on the same page, because got a little bit more further to go on this. So I want to make sure that from that problem there, that you can see exactly what I'm dealing with here. We got the $1,000 winner, the $500 winner, $200 winner, $100 winner, and win nothing. Essentially, what the event is, what X is for each one of those is $9.95, because you got to subtract that you paid $5 to play, $4.95, $1.95, $95, and -$5. The only one that's negative is, the win nothing. Okay? All the other ones you're coming out ahead. Now, what's the probability of winning that $1,000? They're giving you some information right there. They're also telling you of up here some information. So what's the probability of winning the $1,000? How many tickets are there? So there's 2,000 tickets out there. How many of them will get you $1,000? Y'all still alive? How many tickets are there out there? There's 4 of them that are prize winners. So there's how many that are going to get you $1,000? If you can see this, hopefully you should know what I'm going to put up there, right? 1 out of the 2,000. So how many are there $500 tickets? There's also 1 out of 2,000. There's only one $500 ticket. $200 ticket, same thing. And then also for this one, there's only 1 of those. All right. So there's only 2,000 tickets. So we're going to have a 2,000 here as well. And you can think of this as the complement rule. There are 4 winners out of the 2,000. So how many are losers? Can y'all hear me? How many losers are there out of the 2,000? If you pull,
1996.
yeah, 1996, good. So these right here, the last row, that's the probability of each one of those events there. Well, if you're on a computer, I mean, you reload the screen. At some point, you can just reload your tab or reload your browser, and it'll ask you for the to enable the mic. Now, somehow, if that's gotten turned off, then you got to go in your settings and turn it back on. I mean, that's all I can tell you on that. You know, there's just too many. There's too many different different scenarios. If it's a browser, like I said, I use the Chrome browser is all I use. So that's the way you do it on there. If you're on a phone, if you're on another kind of browser, I'm not sure how to do it on that. Because I've tried doing conferences on my phone and there's always something that doesn't go right. All right, now what we're going to do is we're going to multiply multiply the last 2 rows. All right, I'm going to do that down here. So 995 times 1 over 2,000 is 995 over 2,000. All right. So this is a positive 995 over 2,000. We're going to multiply here. 995 times 1 over 2,000 is 495 over 2,000. $195 times 1 over 2,000 is $195 over 2,000. And then this one is 95 in the numerator. Oops. So I'm kind of getting out of the columns. I probably should have just made them wider, but the last one will be for the last column there. All right. Now, here's where it's going to kind of be a little bit tricky to show you this, but this is going to be negative because it's a -5. So I'm going to put -5, and that's 5/1. That's the same reason all of these ended up in the numerator. All right, so we got to, this is what, like I said, they call it the expected value. I think they usually use this like E of X. All right, so we're going to just add all those up. So these are all over 2,000. Let's add all the positive ones up. So what happens if you add up all of these here? What happens if you add up all of these? You're going to add the 995.
1775.
Thank you. I'm going to go ahead and do it.
That includes the -5.
Okay, I'm going to just do it in 2 steps, just so if people have questions, but I thank you for doing that because I like to see someone double checking me. So this is 1780. Oops. Because if you add up all the positive ones, it's 1780. And then this is going to be negative. Now, the 5 is multiplying the 1996. So that's going to be negative 980 over 2,000. So when we subtract, we get 8,200, and it's important, the sign. Is that what you got, Catherine? Or did I mess something up? If I concentrate too much on right on this, I sometimes do stupid stuff. That looks right to me, but 5 times 1996 is the 9980 negative. So I'm going to take it now and rewrite it as just the dollar sign so we can kind of put it in perspective. So it's negative $4.10. All right. Now, it's pretty obvious that you cannot ever either win $4.10 or lose $4.10. What's going to happen is you're either going to lose $5 or you're going to have one of those 4 prizes right there. Well, what expected value does, it gives an indication of how much each person on average is playing to win this. So if there are $2,000 people that are playing this, then the person that's running the raffle is bringing in $4.10. Since it's negative, then it's the player that's losing $4.10 every time they play. So on the average, this is a good thing for, you know, if it's positive, it's good, negative is bad. So that's pretty much it. You can look at expected value in terms of other things too. But these are the most common types of ones that they have in Alex. These ones, they'll have something like with the insurance and stuff like that. You got to make sure. Sometimes they'll take and do that subtraction for you and give you the net amount. Like let's say that somebody's got a $10,000 life insurance policy, but they're paying $50 a year for it or $500 a year for it. You got to remember, that each one of those is a negative for the person paying in or a positive for the insurance company. So just remember, if that's not calculated, if you're not given the net, you need to calculate the net. Because that's why we had to go here and take out that $5, because it's nice to think, well, we're getting $1,000 or $500 or so forth, but it's not necessarily so. All right, any last questions? All right, so I'll see you all Thursday. Like I said, we'll finish up the we might even be able to finish up Thursday, because next week is the last week of the month. So I'd like to have at least 2 days to kind of review and go over the, the practice. So we'll kind of see how it goes. Because I believe then, like I said, once we come back, like in 2 weeks after next week, that's November. October's pretty much gone because Halloween is on the Saturday, and so November 1st is Sunday. So then, like I said, when we come back in 2 weeks, we'd be like at November 3rd. All right.